Here we have the final VedhInc.exe where the UI exe is available, and we have the VedhInc database folder where user manual and it's all related forms, and the recording of this video is also available. So final VedhInc.exe. Here if we go to the dist folder, we have the VedhInc.exe application file. So if we open that, as the previously running UI was there, so we could not reopen that. So I am closing it. If we open now, so the UI is being invoked. Only when the device is connected to the laptop, the UI will be getting invoked. If the device is not connected, we will be getting the error. The device, what we have configured here has the two ports, port A and port B. Here port A is already physically wired, so port B is available for the communication of UI along with the ARINC IC. So COM6 I have to connect. Here we have the TX control, RX1 control and RX2 control blocks, mainly for having the control over the transmitter and receiver channels. Means how the data are being transmitted or how we want to filter the receiver data. So as our device is having 1T, 2R, we have 1 TX control, 2 RX1 control and RX2 control. Apart from this, we have RX status, TX status. RX status is purely for the receiver status, indicating the receiver FIFOs are half or full or empty. And we have PL3, PL1 and PL2 for priority label filter. Whenever the data is available, the green blink will be coming at these positions. And we have TX status, transmitter FIFO full, transmitter FIFO empty, transmitter FIFO half. Then apart from this, we have the mailbox status. MR1, MR12, MR13 are purely for the mailbox receiver 1. MR21, MR22 and MR23 are purely for the mailbox receiver 2. uh, we have the data interaction block here. Once the data we add at the TX channel, loading that data to the FIFO is done by load TX FIFO button. And once the data are available at the FIFO, we can start transmitting. Then we have read RX1 and read RX2. We have master reset and software reset. Master reset is for overall resetting the hardware device. Software reset is purely for the operation like TX control, RX1 control, RX2 control registers are resetted. Full device is resetted with a master reset. Start transmitting, as I already told, once the data are available at the FIFO, we can start transmitting, means the data will be available on the ARINC bus. Then we have a loop back option, means whatever data we are transmitting, we want to loop them, and how many times we want to loop them has to be mentioned here. Then we have a message block here, adding a message, removing a message, duplicating a message. Add a message, when we press it, there will be a entry box at the TX channel for giving the label, SDI, data, SSM information of that ARINC word. Remove a message, removes the last entry of the TX channel. Duplicate a message will duplicate the last entry of the TX channel content. Whenever we want to save the TX channel data, we can go for save TX frame. When we have saved the data and when we want to load them back, we can go for load TX frame. And purely save RX frame is for saving the RX channel data. Then apart from these buttons, we have clear TX messages and clear RX messages for clearing the channels fully. Then we have the setup and export block here. Whatever label setup we uh, want to have with the RX1 can be configured by pressing this button, and similarly label filter what you want to enable with respect to RX2 will be enabled by pressing this button. Similarly, priority setup with RX1 and reading the priority data with RX1, priority setup with RX2 and reading back the data with RX2 is uh, the operation of this button. So these are the channel entries where we can have the data uh, label, then SDI, source destination identification, and SSM is purely for sign status matrix, then the parity. uh, I am resetting the device now. So once I reset the device, here RX status indicate the RX FIFO is empty, and TX status indicates the transmitter FIFO is empty. I am adding a message here. As we have not selected any high or low button here, defaultly it will be taking high, that is the 10 kbps. If we press low, it will be 12.5 kbps. Clear TX messages, it will clear this. Now what all control operation I want to have on the transmitter channel? I want to flip the data with a label and self test, apply, then R flip with respect to RX1 control. Here self test is mainly for internal self loop. RX1 will be having the data as what we have sent, and RX2 will be having the complement of that. Self loop I am checking with RX1, and physically wired loop back I am checking with RX2. RX1 R flip I am selecting. I have not selected any of the label filter or source destination filter or priority label filter here. I am just transmitting the data and receiving the data for the demonstration. Now I am applying R flip, adding a message, label I am giving 0A, source destination I am keeping 00, data I am adding 1 2 3 4 5, then sign matrix I am keeping it 0. Parity, as we have not selected any of the parity here, the parity bit will not be affecting the ARINC word. Once we select any of the parity here, and here odd parity off means now even parity is on. So if I apply and if I press here 1, the word will be getting changed based on the number of ones in the ARINC word. So the based on the odd parity, the last bit of the word is going to be changed. So I am loading the data to the TX FIFO, start transmitting. So here it indicates the TX data has been transmitted, so it has been empty. Some data has been received at the receiver, so here it indicates it is neither empty nor full or nor half. I am reading back that data, read RX1. So what data I sent, I have received back. Now this is just transmitting and receiving. Now I am giving you explanation about the label filter, then source destination filter and parity filter. For that I am clearing the RX channel, adding still more datas. Seven FF is the maximum data we can load. So here R flip, I am giving you explanation about the label filter now. I am setting the label rec, then apply, then transmit the datas, load tx4. So what all label you want to filter has to be mentioned here. Label setup rx1. Here it is giving the decimal values 0a, 10, 250, ff means 256, 0a means 10, then label setup complete, load tx4, start transmitting, read rx1. The data filter is with respect to 0a because ff255 has to be set. As you see here, ff04321 is the data with respect to that, and the ARINC word is matching. Next, source destination filter I am enabling, and SD9 and SD10, if these are not selected, defaultly it will be 00. So whatever data with respect to only 00 source destination identification has to be filtered. I am loading the data, start transmitting, read rx1. So only 00 has been filtered. Now if we want to cross check, SD9 I am enabling. Only the filtered 0 1 means SD10 is 0, SD9 is 1. Only with respect to that what data we had sent, only that has been filtered. Source destination, this one. Then apart from this we have the priority label filter. I am applying that, clearing the RX messages. What all priority label and priority filter you want to enable has to be set up here. Priority setup, hex value, I am giving 0A, then 10, then FF. So priority label set are 0A, 10 and FF. I am loading the data, start transmitting. So here it indicates priority label filters data are available. Here it indicates MR11, MR12, MR13 indicates the mailbox receiver has got the data with respect to receiver 1. Read the priority RX1. So priority status read, and these are the data with respect to that label. 0A means 848D14. Then we have 010C85, and the another one filter which I enabled was 10, that is 08D15A. So this is the label filter. Now I showed everything with respect to the self test, means the self loop back with respect to RX1. Now I am disabling it and I am taking purely the physical wire loop back here. Apply, R flip. Whatever data I have sent has to be received at the RX2 with a physical loopback. There is no any RX2 datas. All data has to be received because I have not enabled any of the filter here. Load the TXV4. Start transmitting. Read RX2. All data have received. with a physical wire connection. I am clearing them now. I will show the source destination. Apply, filter, then load TX frame, start transmitting, read RX2. Only the source destination with respect to 00 has been filtered. I am enabling SD10 and SD9 off, means only 10 data has to be filtered. 10 data has been filtered. Then apart from this label filter, label setup with RX2, 255. Load FIFO, start transmitting, then read RX1, FF. Similarly, priority label, priority setup for RX2, 24, 20 and FF I will show here. Here priority label filters are available with respect to MR2, mailbox receiver 2. So if I read them, status read, so you can match the data here. 24, 1 FFFE, then 20, that is 048D17, and another one is FF 010C85. So this is overall ARINC429 of Vedha Technologies VedhInc.